and welcome to Modeling Algebra. I'm Mrs. McDonald. I'll be your instructor for this semester. I'm looking forward to a good semester with all of you. Congratulations on finding your first video. If you'd like a guide to follow along with the notes in this video, you can go to the notes section in Blackboard as part of our Unit 1, and you can print these out in advance. Let's get started. Today we're going to talk about fraction computations and the order of operations. So a lot of this is going to be review, just number sense, things that you may have seen in previous math classes, but a lot of core ideas that we're going to be using throughout the year. The first thing we're going to talk about is how to add and subtract fractions. If you're adding and subtracting fractions, you need a common denominator. When we say common denominator, we're looking for a denominator that is the same in both or all of our fractions. Sometimes you'll have one that is a common denominator already, and sometimes you'll have to create it. In all of these situations, we're going to have to create that common denominator. The easiest way to do that is to find the smallest number possible that both of our denominators divide evenly into. So let's look at the first example. I have 4/5 plus 8/7. My denominators are 5 and 7. I want to find the smallest number that 5 and 7 both divide evenly into, and that number is 35. That's going to be my common denominator. In order to turn the 5 and 7 into a 35, we need to multiply by a number that's missing, part of our factor. I need to multiply 5 by 7 to make it a 35. But I can't just multiply the denominator of a fraction by something. If I multiply in the denominator, I also must multiply in the numerator. That way, when I simplify 7 over 7, that's equal to 1. Multiplying by 1 doesn't change what something's equal to. It's just going to change the way it looks. When you multiply fractions, you're going to multiply straight across. 4 times 7 on top is going to give me 28. 5 times 7 on the bottom is going to give you that 35 I'm looking for. Let's do the same thing for the next fraction. I have a 7 in the denominator. If I want a 35, I'm going to multiply by 5 over 5. If I multiply my numerators, 8 times 5, I get 40. If I multiply my denominator, 7 times 5, I get 35. Add my numerators together, 28 and 40. I get 68, and my denominator remains the same. That's because if I have 28 35ths plus 40 35ths, in total I have 68 35ths. At the end of any of these problems, you want to decide if any of your fractions reduce. A fraction reduces if the numerator and denominator are both divisible by the same thing. 68 and 35 have no numbers other than 1 that divide evenly into both of them, so this fraction is reduced completely. One way to check that you have a fraction reduced completely is with your graphing calculator, and I'll show that a little bit later. Let's look at the next problem. I have 1/3 minus 1/4. Again, we need a common denominator to do this calculation. The smallest number that 3 and 4 both divide evenly into is 12. Other numbers that you could use are 24, 48, but that means you'll have to simplify your fraction more at the end. So choosing the smallest number is going to save you work. The first fraction, if I want a 12, make that my goal number here, in the denominator, I'm going to multiply by 4 over 4. Again, like multiplying by 1, so it's just going to change what it looks like, not what it's equal to. The second fraction, I need a 12 again, so this time I need to multiply by 3 over 3. In my first fraction, on top I'll have a 4. On bottom I'll have a 12. In the second fraction, I will have a 3 over 12. And now I have 4/12 minus 3/12, which gives me a grand total of 1/12, which does not reduce. One more example. I have 15 over 4 minus 7 over 2. The least common denominator between 4 and 2 is actually written here already. 4 divides evenly into 4 and 2. So that means in this problem, I only have to multiply the second fraction by something to get my common denominator. I need to multiply 2 by 2 to get a 4. So So my first fraction is going to stay the same. My second fraction, I'm going to have a 14 on top and a 4 on the bottom. And now I have my common denominator. 15 fourths minus 14 fourths gives me a grand total of 1 fourth. Multiplying fractions now should be relatively easy because we actually just reviewed it on the last slide. To multiply fractions, we're just going to multiply the numerators together and the denominators together. 9 times 10 gives me 90. 5 times 18 also gives me 90. This is an example of where our fraction reduces. Anything divided by itself is equal to 1. So 1 is the final answer. Let's look at the next one. If I multiply my numerators together, 8 times 12, I have 96. If I multiply my denominators together, I have 15. This is an example of a fraction that reduces. If you have your graphing calculator handy, let me show you an easy way to type in fractions and reduce a fraction. First of all, if you have the newer version of the calculator, so probably a plus or a plus C, something like that, it'll say at the top of your TI-84, you have an extra function built in that's a shortcut. If you hit alpha and y equals, you'll see an n over d. If you hit enter, it'll bring up a numerator and denominator place for you to type your fraction in. So 96, and then if I hit my down arrow, 15. If I hit enter, it will automatically reduce my fraction for me. So this fraction reduces to 32 fifths. So if you compare that to what we had a moment ago, you can see the denominator is divisible by 3, and that got me from 15 to 5. And that same thing happened in the numerator. If I take 96 and divide by 3, I get 32. Please leave your fractions like this. We call this an improper fraction, but it's a single fraction rather than a mixed fraction, which would look something like 6 and 2 fifths. Those are a little more difficult to do calculations with later, so we want to leave them like so. Now, if you have an older version of the calculator and you don't see that alpha y equals enter function, you can type in a fraction by hitting parentheses, the numerator, the division, the denominator, and then end your parentheses. So this is what a fraction would look like, and actually this works in any TI-84 or 83 calculator would have this function. Hit enter. It will give you the decimal version, but a lot of times the decimals aren't exact. We want a fraction. If you have any number you ever want to turn into a fraction, in, again, any of the TI-84 calculators, the shortcut is math, and you can see fraction is right there. Enter, enter. So again, any number that you want to turn into a fraction in reduced form, math, enter, enter is the easiest way to do that. A couple other quick things on the calculator if you're not familiar with it. If you hit second and then mode, that'll always take you back to this home screen. If you hit second on, that'll turn your calculator on and off. If you hit y equals, there we go, that will take you to some places where you can type in equations, and then if you hit graph, that will take you to a place where you can graph equations. Again, things we'll talk about a little bit later on. All right, let's move on to the next problem. Again, I'm multiplying straight across. 6 times 7 on top, 42. 7 times 2 on the bottom, 14. And then it looks like my fraction's going to reduce. I'm going to do this one without the calculator. These are both even numbers, so obviously divisible by 2. If I divide the top by 2, I get 21. The bottom by 2, I get 7. And then it looks like we can simplify a little bit more. 21, excuse me, and 7 are both divisible by 7. If I divide the top by 7, I get 3. If I divided the bottom by 7, I get 1. 3 over 1 is the same as 3, which is the same thing you would get if you put 42 over 14 in your calculator and reduced it. Dividing fractions, we need to remember that when we divide, and I'll write it this way, 12 divided by 1/2, dividing is the same as multiplying by a reciprocal. So I could do 12 divided by 1/2, but that gets a little complicated sometimes. So it's better to say 12 times and then find the reciprocal of my 1/2. Reciprocal means flip it. So I can make it a 2 or a 2 over 1. This is the same calculation as 12 divided by 1/2. 12 times 2, that's something I can do in my head. My answer is 24. Let's try the next one. 3/4 divided by 5/2. And I'll write it out like this. First, dividing by a fraction is the same as multiplying by its reciprocal. So if I find the reciprocal of 5/2, I get 2/5, and now I can do my multiplication. If I multiply the numerators together, I get 6. Denominators together, I get 20. Both of these numbers are divisible by 2. My fraction reduces to 3/10. Again, please leave your answers in fraction form because those will always be exact. The last thing we're going to discuss with fractions in this lesson is how to clear denominators. You can sometimes see these larger fraction problems, or we have fractions within a fraction, which again can get very messy. This is an optional step when you're calculating these type of problems, but it's going to make it much simpler to simplify. To clear denominators, we multiply everything in the fraction by the least common denominator. And we discussed that before. Least common denominator is the smallest number that all of your denominators divide evenly into. In this case, I only have one denominator. My only denominator is 2. So I'm going to multiply my numerator by 2 and my denominator by 2. Again, that's like multiplying by 2 over 2, so I'm multiplying my fraction by 1. It's not changing what it's equal to, it's just changing what it looks like. You have to be careful here to multiply every term in the fraction by that value. 3 times 2 on top is going to give me 6. 2 times 1/2 is going to give me 1. And on the bottom, 14 times 2 is going to give me 28. Now we can simplify. If you have a fraction with addition or subtraction within it, you want to simplify the numerator first, the denominator second, and then divide last. The numerator simplifies to 7. And then you can see we have a fraction that reduces. 7 and 28 are both divisible by 7. 1/4 is my final answer. In the next problem, I have 2 denominators, but they're the same. So again, I can get away with just multiplying by the denominator that I see, 5 in this case. So we're really multiplying this entire fraction by 5 over 5. Making sure to multiply 5 through every term in this fraction. 2 times 5 on top is going to give me 10. 1/5 times 5 is going to give me 1. 6 times 5 is going to give me 30. And 4/5 times 5, we're multiplying 5 in the numerator, which gives me 20. And my denominator remains a 5. Think of it like a 5 over 1 down there we're multiplying in. 4 times 5 on top, 5 times 1 on the bottom. On the top, 10 plus 1 gives me 11. On the bottom, I have 30 plus 20 divided by 5 is going to give me 4. And then I can add those together. 11/34 is my final answer. One more of these. I want to clear the denominators first. To do that, I'm going to multiply everything by that least common denominator. Here my denominators are 2 and 4. We saw those same denominators in a previous problem. The least common denominator between the two is 4. 4 is the smallest number that both 4 and 2 would divide evenly into. So we're multiplying 4 through the numerator and 4 through the denominator. 4 times 4 on top is going to give me 16. 4 times 1/4 is going to give me 1. 4 times 3 on the bottom, 12. 4 times 1/2 on the bottom gives me 2. And you can see very nicely now that all of my fractions have been cleared. 16 and 1 on top gives me 17. 12 and 2 on the bottom gives me 14. 17 and 14 have no factors in common, so it doesn't reduce. I'm going to leave my answer in this improper fraction form. The video will pause in a moment. I would like you to try now to practice a few of these problems on your own. You can answer the questions that go along with these problems, and then the video will continue to play for the second half of the lesson. Okay, let's review the correct answers to these problems. The least common denominator between 6 and 9 could be 6 times 9 if you get stuck, which is 54. You could also find a smaller number by using 18. Oops, excuse me, I don't want to write that there. Let's back it up for a second. Okay, let's review the correct answers. In the first problem, I'm looking for a common denominator. The least common denominator between 6 and 9 is 18. You could also use something like 54 if you want. You'll just have to reduce your fraction a little bit more at the end. I need to multiply my first fraction by 3 over 3. I need to multiply my second fraction by 2 over 2. Here I'll have 15 over 18. In the next one I will have 4 over 18, which is a grand total of 19 over 18. In the second problem, the least common denominator, again, that we're looking for between 4 and 7 is 28. I need to multiply the first fraction by 7, and I need to multiply the second fraction by 4 to get to my denominators to match. In the numerator of the first one, I'll have 49. 7 times 4 on the bottom gives me 28. 5 times 4 on top gives me 20. 7 times 4 on the bottom gives me 28. And now with my common denominator, I can subtract. If I have 49 28ths, take away 20 28ths, I have a grand total of 29 28ths. The next problem, we multiply straight across. Negative 10 on top, 18 on the bottom, and this one does reduce. They're both divisible by 2, so I have negative 5 over 9 as my final answer. In the next problem, we're going to rewrite, instead of division, as multiplying by a reciprocal. So the first fraction stays the same, the second fraction flips. If I multiply straight across, I'll have a positive 54 on top and a 28 on the bottom. Both of these numbers are divisible by 2, so we'll start there. If I divide the top by 2, I get 27. If I divide the bottom by 2, I have 14. Nothing that these numbers have in common, no common factors between 27 and 14, so this is our final answer. In the last problem, a good optional first step, if you don't want to mess with all these fractions and common denominators, is to clear the denominators. We're going to multiply by the least common denominator. Right now I have a 3 and a 6. My least common denominator is 6. 6 will get multiplied in the numerator. 6 will get multiplied through the denominator. 6 times 2 on top is going to give me 12 thirds plus 24. 6 times 3 on the bottom gives me 18 minus 6 times 5 on top, 30 over 6. 12 over 3 gives me 4 plus 24. 30 over 6 gives me 5. My numerator is a 28. My denominator is a 13. Those two numbers have no factors in common, and that's your final answer. The next thing we're going to review in this lesson is the order of operations. The order of operations is the order in which you simplify an expression that contains multiple operations. PEMDAS is one way to remember it. Another way to remember it is please excuse my dear Aunt Sally. Hopefully this is familiar to you. P stands for parentheses. E stands for exponents. M stands for multiplication or multiply. D stands for division or divide. A add. S subtract. So if you have multiple operations, the first thing you'll do is simplify with the parentheses. And if you have more than one parentheses, you work from the inside out. So you simplify the innermost parentheses first and so on and so forth. Then exponents, which are sometimes called powers. And then at the bottom here, this is where it gets a little tricky. Most people remember the order, but they don't remember the fact that multiplication and division are actually a pair. They happen at the same time. The same is true for addition and subtraction. We complete multiplication and division at the same time from left to right. So an example of when division might come before multiplication is a problem like this. If I go from left to right, I would first do 7 divided by 4 and then multiply by 3. Some people will look at that problem and forget this fact and do the multiplication first. The same is true with the addition and subtraction. So let's do a little practice with this. If you have a fraction, we kind of talked about this earlier, treat the numerator and denominator like a parentheses. You want to simplify the entire numerator first, the entire denominator second, and then divide at the very last step. Within the parentheses I've written there, the first thing I can do is exponents. 2 squared gives me 4. And by the way, if you're looking for the squared key on your calculator, it looks like this. It's right above the division key on the right side of your calculator. So you would hit 2 and then that upper facing arrow and then another 2 and enter. It would give you 4. And then I'm just going to bring everything else down that I know, like so. If I continue now to simplify inside that parentheses on top, I'm going to get a 0 over 5. And 0 divided by anything gives me 0. Quick note, if you ever have something divided by 0, we can't divide by 0 mathematically, so we say that is undefined. Next problem, I'm going to go ahead again and put parentheses around my numerator and denominator. In both the numerator and denominator, again, the first thing I can do is an exponent. So I'll have 4 minus 3 squared, which means 3 times 3 gives me 9. On the bottom, I'll have 25 minus 5 squared, which is 25. My numerator simplifies to negative 5 inside that parentheses. My denominator simplifies to 0. And actually, maybe I didn't need that note on the last example. We have it right here, an undefined value. Finally, the last problem. If we go through our order of operations, the first thing we're going to do is parentheses. By the way, brackets are also considered parentheses. They just write them a different way so you can distinguish which pair go together. Because I have 2 sets, we start from the innermost parentheses. The first thing I can simplify in this problem is 2 plus 6, which gives me 8. If you don't have an operation between a number and a parentheses, that means multiplication. So again, continuing to simplify inside my parentheses, the 8 on the inside there, nothing else I can do with it. If I have subtraction and multiplication, the order of operations says do the multiplication first. So 1 times 8 gives me 8. And then if I finally simplify that bracket, 4 minus 8 gives me negative 4. Minus 3 for the last step, do my subtraction, and I will have negative 7. Let's try a couple more. Again, I have multiple brackets and parentheses. Let's start from the innermost parentheses. I'm going to carry everything else down. 8 minus 3 gives me 5. Continuing inside that bracket or parentheses, I have, again, multiplication and addition here. Multiplication comes first in my order of operations. To finish that bracket, I'm going to do 8 plus 15, which gives me 23. Remember, if there's no operation, it means multiplication. So if I have addition and multiplication left, I'm going to multiply 3 times 23, which gives me 69. Add them together. The final answer is 70. In the last problem, again, I start on my innermost parentheses. 8 minus 3 is all I can do there. It gives me a 5. Then, continuing inside the brackets, I have multiplication and subtraction. I'm going to multiply first. Then to finish the bracket, 25 minus 20 gives me 5. And finally, I'm going to square 5, which means 5 times itself. Final answer is 25. The video will pause in a second. Take a few minutes to try these on your own. Answer some questions about what you find, and then the video will continue and I'll explain the answers. In the first problem, my numerator can be simplified, and I could do both exponents here at the same time. 3 squared gives me 9. 4 squared gives me 16. If I finish that numerator, subtracting will give me negative 17. Not 17, I said 17, negative 7. And on the bottom, I have 16. That does not reduce. The final answer is negative 7 over 16. Number 2, numerator and denominators. I'm going to put in parentheses. And again, the first thing I can simplify in each is the power. So 6 minus 4 squared, which means 4 times 4, gives me 16. In the denominator, 3 squared gives me 9, minus 9. And hopefully you noticed at this point, we have something minus itself in the denominator. It doesn't really matter what's in the numerator because anything divided by 0 will be undefined. For number 3, I first simplify my innermost parentheses, which gives me a 2. Then, continuing inside the bracket, I multiply first, which gives me a 6. Then I subtract second, which gives me a 1. Then, with what I'm left with, I have multiplication and addition. I multiply first. 2 times 1 gives me 2. Final answer is 6. In the last of these examples, you should have done, again, the innermost parentheses first, which would give you a 3. 4 times 3 to my multiplication gives me 12. 12 take away 10 gives me 2. Last step is to square it, multiply by itself, I get 4. I hope you're noticing in each of these all the work that I'm showing as I'm going through the problem. Please make sure if you're ever submitting anything, a test, a quiz, an assignment, as they come available where you may need to show work for something, that you're writing out every step you're doing. Not only does it keep it organized for you, but it makes it easier for me to see where you make a mistake, and I will do my best when I'm grading to give as much partial credit as possible. A few other things that we're going to review very briefly in this section. The first is absolute value. Absolute value, officially the definition is the distance to 0. So a lot of people will look at it and they'll say, well, whatever is inside it, we're going to make it positive. Really, it means how far away are we from 0. And we treat absolute value like a parentheses. We do order of operations, simplify what's inside it first. Negative 7 minus 4 gives me negative 11. The absolute value of negative 11 is 11 because negative 11 is 11 units away from 0. The next thing we're going to review is the distributive property. The distributive property says if you have a number or a variable multiplied by a parentheses that contains more than one term, so addition and subtraction between them, you must distribute that number into each term inside the parentheses. We were doing this a little bit actually with our fractions when we were clearing those denominators. 5 times x gives me 5x. 5 times y gives me 5y. And then whatever your sign is, you just carry that over. It is possible that you will be distributing a negative through a parentheses. If you have a subtraction sign in front of a parentheses, what that actually means is you have a negative 1 multiplied by that parentheses. So the first thing you're going to do, think of it kind of like an order of operations for simplifying, is distribute in that negative, or think of it again as negative 1 times each of these terms. Negative 1 times 2x is a negative 2x. So you could write minus 2x or plus negative 2x would work. Negative 1 times 4 gives me a negative 4. Again, you could put plus negative, or you could just write minus there. Then notice we can simplify a little bit more. I have a 6 and a negative 4 I can add together, which is 2. Minus 2x is not a like term, and actually we're going to review that in the next piece here. When you combine like terms, you're looking for terms that have the exact same powers and the exact same variables. So if we're looking here, my terms have the same coefficient number in front of each of them, but one has an x and one does not. So they are not like terms, and that's as far as we could simplify. If we're looking at the problem on the bottom, I have several sets I can combine together. For example, I have a 6x to the fourth, and I have a negative, so a negative 1x to the fourth. If I add those terms together, I have a 5x to the fourth. Then, if I'm going in what we call descending order, exponents highest to lowest, it's a good thing to get in the habit of writing those. It's going to make some problems easier as we move through the semester. I have negative 4x to the third. Then I have a negative 3x. I think I had its own buddy. And a positive 2x. If I add those together, I'm going to have a negative 1x. And then my last term, again, no buddies, a positive 6. So notice when I'm combining these like terms, the variables themselves are not changing. X to the fourth, x to the third, negative 1x, 6, all of those pieces are remaining the same. The only thing that happens when you are combining like terms is the coefficient, the number in front, changes. The quantity of how many variables you have are changing. If I said I have 6 apples and I take away 4 apples, I'm left with 2 apples, but there's still an apple. Think about a variable as an apple or an object. When you're combining them together, you're combining them and determining how many you have in addition or how many you have remaining, but the item itself doesn't change when you add or subtract. Here's again some practice for you. Let's go through the solutions. Order of operations tells me to simplify inside my absolute value. 2 minus 8 gives me negative 6. The absolute value of negative 6 is positive 6 because it's 6 units away from 0. And actually, when I take that absolute value and make it a positive 6, we can really just turn that into a parenthesis. So let me do that. Finally, I multiply. Negative 36 is the final answer. In the next problem, I do have something to distribute, a number multiplied by my parentheses. 4 plus 5y. I can bring down. 3 times 2 gives me 6. 3 times 6y gives me 18y. And it's subtraction. Because you have addition between these parentheses, you actually don't need the parentheses at all because we've already taken care of everything that needs distributed. You also can't simplify anything within the parentheses because 4 and 5y, 6 and 18y are all different terms. So at this point, if you drop the parentheses, all you can do is combine the y's, 5y and negative 18y. Combine them together to be negative 13y, 4 and 6, which give you a 10. In the next problem, you have two things to be distributed. Negative 2 is distributed through the first parentheses, and negative 1 is distributed through the second parentheses. You should have gotten a negative 16x, a positive 2y, a negative 4x, a negative 9y, or if you have plus negative 9y, that would work as well here, plus 1. From there, we can combine together any terms that have the same variables. A 16x and a negative 4x gives me negative 20x. A 2y and a negative 9y gives me a negative 7y. And finally, plus 1 has no buddies. I'm going to bring him over. In the last problem, there's nothing to distribute. You're just going to combine together any terms that have the exact same variables. 6xy and negative 4xy gives me 2xy's. 2z has no buddies. 8y has no buddies. And negative 7xyz has no buddies. So all of those terms we'll just bring down. And although some of these terms share like variables within them, there are no variables, no terms now that remain where every variable in each of the terms is exactly the same. So this would be your final answer. The final thing in this lesson is an introduction to polynomials. In a few days, we'll get a little more into detail with this, but on your homework on My Math Lab, you will have a few problems that have to do with just the terminology. The definition of a polynomial function is really quite intimidating. A polynomial function is a polynomial in variable x and degree n and is defined as such. And there's a lot of notation that goes along with this. And it says where each a sub n is a real number and n is a whole number. What this definition means, if we see all these n's and the a's in front of them, a sub n minus 1, a sub n minus 2, etc., etc., those are all just coefficients, and they're all real numbers. So if you've ever talked about imaginary numbers in a previous math class, those will not appear with polynomials. And then when you look, we've got a variable in each of our terms, an x in this case. We also have n's. Those are our powers. N, n minus 1, n minus 2. Notice they're in descending order. They're getting smaller and smaller as the polynomial continues. And the only condition on n is n needs to be a whole number. The set of all whole numbers are your counting numbers including 0. 0, 1, 2, 3, etc., etc. So what this means is a polynomial is going to look like a number times a variable to a whole number power, plus or minus a number times a variable to a whole number power, etc., etc. And this is an example of one. So you can see I start out with a coefficient 4 times a variable to a whole number power 8. And then it's minus here, but you can think of it as plus a negative. A coefficient times a variable to a power. Notice all of my variables, the powers on them, I can think of this like an x to the first if you don't see a power on it, are going in descending order. The final number, if you have one that does not contain a variable, you can think of it like an x to the 0 power. Anything to the 0 power is equal to 1, so adding that or attaching it to the end of my number doesn't change it, but not something that we're ever actually going to have to do a calculation with in terms of polynomials. This is what, again, we call a polynomial in standard form because those exponents are descending, highest to lowest. We say that the degree of this polynomial is 8. The degree in the definition is n, and you'll notice that n is the first power that we see when the exponents are written in descending order, highest to lowest. So what that means is, a simple definition for degree is it's going to be your highest power inside your polynomial. A constant is a number that does not contain a variable. Sometimes you'll have these, sometimes you won't. Our problem in the example did have one. 7 did not contain a variable, so 7 is the constant. Leading coefficient, again, coefficients are any number in front of a variable. So 4, negative 5, 3, 2, 7, those are all coefficients. The leading coefficient, again, when my terms are written in order, is the first one. So that is 4. You may have some problems on your assignment that ask you if something is or is not a polynomial. Sometimes it's easier to determine that something's not a polynomial because you can find something wrong with it. If you see any of the following things in an equation, it is not a polynomial. Roots, so square roots, cube roots, fourth roots, those are not polynomials. If you have exponents that are negative numbers, fractions, decimals, that is not a polynomial. Finally, if you have variables in a denominator, it's okay to have fractions as a coefficient in front of the term, but you can't have a variable in a denominator. That actually means you have a negative exponent, which is already something that's listed as a no-no here.